Hello, my name is Andrew. As John said, I'm actually Principal Structural Engineer. What I've cobbled together essentially is something that tackles civil and structural engineering. I haven't really dealt with the building services aspects of BIM. So, right, flip. Also the first person to tackle the erratic remote. Loosely, the things I was going to work through today was essentially some illustrative examples of projects that we've done recently using BIM. Some aspects specifically of BIM in civil and structural engineering, how we've approached these projects in these disciplines, the issues that we can see that need addressing. Some of this will cover slightly what Steve's covered and also David before, and obviously the future benefits of the adoption of BIM. So, come on. I dare not press it twice in case I jump 2 slides. There we go. Oh. Disaster already. As I said, the first couple of slides are just some illustrative projects. So the first one I've got is not a school called Notre Dame Catholic College, which is one of my own projects currently on site in Liverpool. It's about a £16 million new build school. The second one is a job that was completed last month, a little bit more local. It's the Palatine Centre at the University of Durham. This one was about 33 million or so, was completed with Lang O'Rourke. This was one of 2 buildings. The other one features in some later slides. Sorry. And I put this one in because when we've been using BIM and the 3D model and all the other aspects that come with it, the things that we can now generate that we previously couldn't use in the 2D CAD, or the sort of graphical images, if you like, obviously the 2 that preceded this are other examples, but we find this extremely useful in demonstrating things to clients, illustrating options. I mean, this was an apartment block, as it said, in K30, but we're starting to do this quite early doors on a lot of projects when we can quickly build models or several models to look at different framing solutions or different material types, so on and so forth, and it helps inform clients and makes them think that makes them a better, sorry, I'll start again, allows them to make a better decision on how they think the project's going forward and whether it matches their own briefing expectations. Big pause. Yep. And a more local job. I mean, this is a render of a job that's in Cramlington that we're working on with riders. This one wasn't actually generated by us. We sent this out to a 3D rendering company. But again, it's an excellent image that we can use to discuss things with the client as the project moves forwards. And this last example is a slide that we quite frequently put into presentations that we give to clients when we're bidding for projects. This is actually the other building of the Palatine Centre that was on before. And essentially it's to try and demonstrate how we integrated the BIM process on a project through one that we've done recently. So working left to right, we've got our own model. The second from left picture is a combined model with the architecture and also the M&E, albeit obviously you can't see it on that. And then how that rolls into the construction process and also ultimately the completed building. And at the back on the table there's a couple of drawings and some other graphics of this particular project, because Lang O'Rourke as a company obviously tried to advocate the use of BIM in off-site manufacturing, and this particular building was all precast concrete, and their aspiration was to actually never to touch a piece of paper. So it was to try and get it from our model through their CAD/CAM models actually manufactured and turn up with zero waste and various other issues, but didn't quite work according to plan, was being brutally honest, but it still looks very impressive at the end. And this particular slide, I wasn't going to rattle through all of the things on it, but the main thing really, obviously from my point of view, is it's very easy to list a lot of benefits that we can gain from using BIM and 3D model and all the other information that comes with inherent in the models. I think just flicking through a couple of them, the one that we find extremely useful is the fourth one down, I think it's fifth one down, where it says links to analysis software. From our point of view, historically, we've either had a drawing model and an analysis model. We've never had our model. And what we're doing now is we can use the same model and flick it back and forwards between the analysis software and the drawing software, and they're always running concurrently, and that allows us to economise our own time, but also make sure that they're both consistent and that we don't end up with issues later on if something hasn't been picked up on one or the other. And further down, there's obviously benefits to the people at QSs. We can schedule things out, we can produce materials. Internally, we've been doing an exercise from a sustainability point of view on embodied energy. So we now produce our own schedules from our models that, whilst they might not go out to other people, we can then apply parameters that we've generated in terms of embodied CO2 for reinforced concrete, structural steelwork, so on and so forth, and actually use that as essentially as a design criteria. So we can try and refine our own designs from an environmental point of view as well. You need some new batteries, John. I'm sorry. It's terrible. And this is a slide, again, that we quite often use as well to demonstrate to clients, and that loosely called this internal BIM, but it illustrates how we work internally using the models and the inherent data, the geometric data, the material data, the structural analysis data, the forces and so on. So there's never really, we never find a specific point to start in the middle circle. Occasionally we'll take an architectural model, start that. Occasionally we'll start our own analysis model. And generally I would say we'll start a drawing model first, but there's no real specific starting point. We go around and obviously there's iterations off into the analysis software back and then spitting things out into an architectural model, albeit theoretically it's a project model. And it works very well, to be quite honest, and as I say, it tends to make our time slightly more efficient. I wouldn't say 100% more efficient, but it's heading that way. And again, I mean, I'm not a civil engineer by any stretch, but there's a list of issues here that how BIM's applicable to civil engineering. So you've got the cut and fill quantities, the 3D model, the inherent data. It's very much, I suppose, analogous to the structural engineering as well, to a degree. So very briefly, how we've tackled the adoption of BIM. It obviously, it hasn't been a sudden thing. We've been using 3D model and analysis for years and years, but more recently we're starting to get at this project model and integration with architects and the M&E engineers. But essentially we've had to make an investment in the software, the hardware, and a big investment in the training, which is starting to pay dividends as we get more and more into it. We would say that you definitely need to be committed to making the change. It's not something that you can just sort of do half-arsed and do a little bit here and a little bit there. You really need to say, I'm going to do it, and dive into it. And obviously, there's always a reason not to do it, but the best thing to do is obviously knock them on the head and get on with it. So we now have taken the plunge to use BIM on all jobs. This is from a civil and structural point of view. We're kind of a little bit behind in terms of the M&E, but I would say that's probably a reflection on the industry as a whole, not specifically us. And we also use BIM and all the things I just mentioned on projects whether other people are using it or not. I would say we're a little bit behind architects in terms of how they use it and what they use it for, but we're probably ahead of M&E engineers and especially subcontractors and subcontractors. I think at the minute, how projects seem to develop is you get to the point with the architect where it gets issued and then essentially it just drops off a cliff. And a lot of times where, and there's some of the points on the previous slide, if you caught them, where the model could be sent to a steelwork fabricator, say, but he gets it and then he goes back to how he's been doing things for the last 30 years, where he just prints all the drawings out of it and then traces the whole lot back into another model. Well, it's not really using the model in the BIM process at all, to be quite honest. So, and then the last point, as I said, we've now using structural Revit, BIM, whatever you want to use on all. I've put more than 95% projects, but essentially that's because we don't design lintels for garages and things using BIM. Bits and bobs like that's not really worth the effort. And there's a few points as a tail off, just on our internal view of the current situation in the industry. I think the main thing to take from our point of view, what we've learned, is it's a new way of thinking, a new way of tackling projects. There's a lot more forethought needs to go into it, and you can't just dive in and draw things and as perhaps we might have used to. And then I think we've now got combined projects with a contribution for the full design team aren't very common. I'm just repeating what I've just said, to be quite honest. And the last one, maybe a little bit controversial, I suppose, but lots and lots of talk, but not so much of evidence of take-up through the industry. But that I would say is mainly on the contracting side rather than on the consultant side. Issues to address moving forwards, and I've left all these hanging essentially as questions because they're all things that we think need sorting out, not today, but over the coming few years, some of which have been alluded to in the previous presentations. Responsibility for the model. Currently we sit with individual models and it's obviously fairly clear who takes responsibility for what. With the project model, issues become a little bit blurry. Project insurance was mentioned previously, would come into play. The cost of the model, if the expectation is to do more work, more clash detection, essentially more design coordination, is there an argument that consultants' fees should increase, or is it they should stay the same but the allocation of fees through the run of the project are divided up slightly differently? It's something that is probably one to ponder as well. I suppose that leads into the second one. It's the same argument but applied to time. If we're doing clash detection to remove risk in the contract, the construction period reduces, does the whole project period maintain the same overall durations, just there's more upfront, less on site, which is Langer Rock's essentially expectation and an aspiration. Why the take up in subcontractors? And one that I tagged on the end was who develops the as-built model for the client ultimately, because obviously things as they go on theoretically aren't always built exactly as they're modelled. So if you have an as-built model that you're relying on for future-proofing, FM, whatever you're going to use it for later, who actually does that? Is it the contractor's responsibility, or is it the contractor provide all the information back to the consultant team? I don't know the answer. It's probably one for future debate. And I think, John, at a very 100 miles an hour speed. Oh, sorry, there's one left at the end. There you go. And the future benefits, again, a lot of these have been covered already. I think these are moving more into the level 3 BIM. We're not there at all at the minute, I don't think. And the CDM one, I don't think at the minute doesn't seem to be getting much of a look in. I don't think we have a CDM man on our BIM Hub committee. Correct me if I'm wrong. Well, you're acting as chair rather than as CDM man, I think.
Sorry about that.
Well, to a degree, you know where I'm coming from. I think you're acting more as a chair rather than with the CDM hat on. But the opportunities there to put the more information into the model, how we tackle that, I'm not too sure at the minute. But the residual risks, at the minute we just churn out 3 sheets of A4 and they get thrown at the back of a file whether anybody ever looks at them later. Questionable. If we're going to have a digital representation of the facility in the building, surely everything should be contained somehow within there. So, and that definitely is the last slide.
BIM Academy is a JV between Northumbria University and Ryder Architecture. And it came about, also it has links with other academic institutions and other partners in industry as well, so they were the founding members of the organisation, but we do have strong links elsewhere. Our aims really are to support industry in the adoption of BIM, develop the skills of the workforce, promote collaborative working, multidisciplinary working, promote innovation and research, and also to be independent and impartial in the advice and support that we give. So we're delivering support to industry through consultancy. We're supporting university in the incorporation of BIM into the curriculum. We're also running CPD and training. And Steve Lockley and his team are doing a lot of research and development in this area as well. If anyone's seen a presentation by me in the past, you may have seen this slide. I'm not going to go through each year of the timeline, but really what this says is both Northumbria and Ryder both were early adopters of BIM technologies. They both recognise the benefits to the service that they offer their clients, whether they're undergraduates or developers, and realised probably over the last 3 or 4 years that the industry needs to step up in tandem to be able to operate within this environment in this way, because there's nothing worse, as Andrew's alluded to working in isolation in BIM. There are limited benefits, but you don't really realise the benefits until you're working in a truly collaborative way with the rest of the team. So some case studies. These are derived from work within RIDER, also from the university's work over the last few years. Some of these projects, most of these projects actually go back 3 or 4 years to a point where RIDER started using BIM on all new projects from 2008. So you've got a range of schools projects here, from a small primary school in Northumberland through to Durham Johnson School in Durham City. Major benefits gained through management of the information more effectively, better design coordination, all the stuff you've probably heard before, but it does actually work, and there were real benefits. The tangible benefits on Durham Johnson is that we had a team at a peak of 3 people working on a project, £25 million project. 2 years before that, we'd had a team of 7 or 8 people. That doesn't mean the technology solved it all, because it relied on very careful project management, design management. But as a result of that, it became a very profitable project for the company. What we have found is if we're working in isolation and you're then working with people in a 2D environment, those benefits have very quickly lost. Just some other examples on the right there. We did some work on Harton Primary School as part of STAG BSF, South Tyneside Schools, where we trialled the use of pedestrian modelling software to model pupil movement. Now that technology is normally used for fire engineering, but we thought, why not use it to try and make sure the classroom doors are big enough in the right place. And we've also tested the use of cost management software on the same project. Another local example, 2 sets of student accommodation in the centre of Newcastle. 450 student flats in each block, a lot of repetition in the design. The Victoria Hall project next to the Central Motorway on the top right, that had been in gestation for like 6 years or something, because it's gone to planning appeal. It just went to appeal and appeal and appeal. We're up to revision 20 or 25 with the drawings. This was all done in AutoCAD, of course. We suspected the design needed a bloody good audit before it moved any further onto site. We remodeled it using Revit. We found a number of inconsistencies. We were able to manage the repetitive nature of the design very effectively, and we turned around a project which probably would have made a big loss into one that made a modest profit as a result of that. We also started linking elements in the models to specification. This was before the advent of National BIM Library. Another example, Freeman Hospital Institute of Transplantation. Again, use of architectural and structural models to manage a very tight space budget on the project. Design coordination, managing or tracking room areas, helping with the FF&E process as well. There's a lot of medical equipment in projects like this. And also to be able to deliver high quality visualizations to help the end users understand what design they're actually going to be delivered. This is some 4D construction simulation on another project in South Tyneside, Cleedon Park Primary Care Centre, where we're able to take the construction programme and link it to the model to simulate the construction process. It was a greenfield site, relatively unrestricted, but it demonstrates that using those technologies together does allow a contractor to gain efficiencies in programme, and also there's a health and safety benefit there as well, I think, particularly on constructed sites. Virtual Newcastle Gateshead. This is the city model which was instigated by Northumbria and Newcastle and Gateshead councils in about 2008. Both local authorities use this to inform planning applications. It can be used for visual impact assessments, such as the Gateshead Town Centre images in the top right, to measure the planned or the designer's aspirations against the reality of the city model. The image on the top left allows a particular structure or an element in the city to be assessed for its visual impact. That's St James's Park in the top left. The orange areas are where in the city centre it's visible from street level. City campus model for Northumbria. About 4 years ago, the Northumbria were asked by the estates team whether we could create a model of the entire city campus as a placeholder for asset management information. This doesn't necessarily mean to manage an asset. You definitely need to create a 3D model of everything in the portfolio. But in this case, the estates team felt that was beneficial. So the Revit model, which was created using a mixture of 2D to 3D conversion and also laser scanning, has been used for tracking room loading, furniture, managing critical assets, recording presence of asbestos in the Ellison building, for example, on the left. And we've also done some trials on the use of Autodesk Project Vasari, which is a tool to allow energy modelling to be assessed. So it's a bit of a test bed, this model, for a number of FM uses. In terms of industry support that we've been able to provide from BIM Academy, we've advised a number of clients on BIM implementation BIM implementation planning. Somebody once said that in BIM, the time isn't spent in the modelling, it's actually in the planning at the front of the project, because don't underestimate the need to ensure that things like levels of development, the structure of the models, the actual BIM uses to be adopted, the format in terms of how information is going to be shared, all need to be agreed and planned up front, which is where a BIM execution plan or BIM implementation plan comes in. And we've been able to help a number of clients with this type of work. We've provided support to MBS on the creation of a National BIM Library, which is a free online generic BIM object library, available in a number of software formats to support the use of intelligent data within the industry. In terms of in the field of education, we've had a number of graduates work with us over the last 18 months, mainly from an architectural background. We'd like to have more engineers, I think, in there. And these people have all moved on to progress their careers elsewhere in industry, either back into architectural profession or working with contractors. In the case of Naheem, actually becoming the BIM leader for the FIFA World Cup 2022 in Qatar. So we're very proud of the success of the graduates who have moved through our enterprise. Northumbria has recently launched an MSc in Building Design Management and BIM. That starts in September this year with a further intake in January. That's available as an MSc and a postgrad certificate. And we're also able to provide, we provide either software training for the graduates within the team or bespoke training for members of the industry who need it. And we've done a number of speaking events around the country for a number of institutions and industry bodies, and run our own seminar series as well. In terms of research and development, we've been involved in a study for RAP, who the government body looking at resource efficiency, waste reduction, doing a couple of studies with them over the last 12 months, looking at how the availability of BIM tools and how they might be applied to the waste reduction processes that RAP already has, and how they may be turned into a BIM environment. The ISIM tool, which is a carbon modelling tool, which allows designers to optioneer a number of design options and test the embodied carbon content of a design as it evolves. Again, that's been developed with Northumbria and our IBA enterprises and other partners, including BISRIA and Autodesk AEC3. Yeah. For BIM, this is a tool, again, it's an IFC-based asset management tool, not just asset management, a collaboration tool, which is a technology strategy board project with a number of industry partners. Just thought I'd mention this collaborative competition we entered in the summer, Build London Live. Most of the parties who were involved in that were based in the region, with the exception of Fulcro from the West Midlands. But within a 48-hour period, we managed to plan and implement a very complex design for a museum for 2012 in London. And we won the prize for Best Multidisciplinary BIM and Use of Interoperability, which is a bit of a mouthful, but it just shows what can be gained by planning and working in this way in a multidisciplinary environment. So we were able to deliver cost plans, 4D logistic planning, all the principal design disciplines were modelled, and some pedestrian modelling as well, so we're very pleased with that.
I'm from Space Group, but within Space Group we've also got BIM Technologies, which is really a response to the changing environment. And what we're going to do is particularly talk about one project, which happens to be, can I flip the next slide there? Happens to be, that's fine, happens to be in London, because the Geordies are heading down south. You've got the impression from the where BIM is going. I'm joined by Adam, who's our technology leader in BIM Technologies, because at the end of the overview of the project, he's going to drive the model and kind of talking and driving the model bit too difficult. But, so the area we're going to talk about is project process, not necessarily about the technology, because to be frank, the technology is easy. The people bit's the hard part, and the role of the BIM coordinator, which is the role that we're carrying out quite a bit at the moment around the UK, which is kind of filling a skills gap. We'll talk about Blackfriars and then the demonstration. Cheers. So yeah, we focus very much on, there's no T's as in technology, but there's very much three P's: people, protocol and process. That's a big part of BIM for us, and probably the most important one. And all the things you've seen today and the demonstrations you've seen from Kundals and the rest of the guys, it's always the people that's the biggest challenge, and that's, I guess, the hardest challenge in what the hubs are trying to achieve. It's the people bit, because the technology's there. It's there now. It's actually ahead of where we all are. I've seen some interesting things over the last few weeks where technology is actually ahead of where the thinking is. This particular project, where we're acting as BIM coordinator, tells a good story about the people side of things and the technology, and is probably pretty much a state of the art at the moment. This is on site now. It's in London. It's just off Blackfriars Bridge. It's a £70 million, 16, 17 story tower. What's interesting about it is it's a private sector developer, and this particular Great Portland Estates, they've got a £1 billion development fund, and they're buying into BIM. They're not buying into BIM because it's a cool thing to do, or they want to be trendy, or the first people to do it. They're developers, so they're hard nosed. There's only one reason they're doing it, and that's about improving their product and improving their business. There are public sector clients doing it, but very much for them it's about the process improvements. So background of the project, we got involved. One of these projects got stalled. Three individual consultants, architect, engineer, and structural engineer. The three engineers come together. Two engineers come together with the architect. They were working in total silos, absolute no coordination. They had some quite good information together. Our role basically was to bring all of that together in a single environment. So the first thing we have to do is get a skills review, see where the team's at, and we're doing that more and more. What we're finding is a lot of people are saying they're doing 3D, but actually what we have to kind of go down is really delve and say, are they really doing 3D? Now, the architect was doing 3D. He told the client he was doing 3D, but his 3D was SketchUp. So the client thought he was getting 3D, and one of the issues with BIM is that clients think they're getting it, but actually they're not. So we have to really, as BIM coordinators, have to really go in and pick and actually say, in reality, this is not BIM. You're not going to get the best value out of it. Go to the next slide, Adam. So yeah, as I talk about, it is the usual suspects, and looking from the skills point of view, the client had very little knowledge of BIM, had read a bit about it, but kind of was quite passionate about it, QS by background, but wanted to deliver it in his project. So he's passionate about it, but wanted some advice. And I say the consultant team were fairly low in their skill level. MEP very, very good, which, to be frank, is unusual, because actually MEP is, in all the consultants, a little bit behind. But actually the consultant, they were the strongest part of it. So once we'd actually kind of unpicked it, there was massive resistance from the three existing consultants for us getting involved. Didn't want another, what are you guys coming in for? What are you here for? Our point is that we're here to help and stitch everyone together, help on the coordination side. So initially there was a real resistance. The client said, look, give it a go. If after a few months you aren't getting the benefits of BIM, I'll walk away from it. I say we've come through the full process now, and they've already bought into it. So once we've kind of got to the bottom of what the team's doing, we can then, as has been touched on before, is getting the protocols right, because the team had set off on a journey designing information, all with different processes, different protocols, different standards, so the models were never going to talk. So the first thing we had to do was standard protocols and processes. An example being when we brought the models in together, one was 54 kilometres south of the rest of them. So it's that simple thing of bringing them together. So the first thing is to get standards. And it's like, for me, BIM's dead simple. It's just like a database. And any database you do, you've got to get everyone using the same terminology. It's no more complicated than that. So it's the protocols first, and then set the processes in place of the team working together. Then got to go live. So all of that bit up there is just paper and theory. That's, in some respects, the easy bit of BIM. The hard part of BIM, a lot of people are writing protocols, project execution plans. How do you get from that to a project? How do you deliver it? And that's the hard part, because you've got to get people to buy in. What we did, we had a BIM launch meeting, so we got everyone in the room and really pushed it hard. And then when we get down to actually delivering it, it's about meetings, regular meetings, uploading information, where you're going to put all those simple things, and just effectively getting on with it, but driving it hard. And I think the biggest thing was the support from the client, saying that there was no going back from this. And then I know David's talked long and hard about data and data sets, but it is very much about getting that consistent information in there. And what's happened at the beginning of the process, the client was very keen just to set these parameters quite small, which was quite good. He said, look, all I want to get out of this is some good quality clash detection. I don't want to do any more than that. I just want an integrated model. As we've gone through the process, his eyes have opened a lot more, and he's now seeing, as a private client, Great Portland Estates, thinking about the asset management and how we can take it further. So he's grown into it, which is very good. Now the data information, and he's now looking at FM and how can he get the benefits. We're looking at how the information at the end of the project and as built can be delivered. And I know that's kind of come up in a few people's discussions. I honestly don't think it's an issue, to be honest. And then we'll move into the construction procurement stage. We brought on Mace. Mace went through the tender period. The tender went out on the basis that they had to respond to a BIM project. They got involved at Stage D, and Mace have been very closely involved at developing the Stage D model to Stage E, and we've done that together. And then once we've got to Stage E, we're now moving towards bringing the trade on board. So it's a really evolving model as we've gone through. When we got to the end of Stage E, we had stretch a point to say 0 clashes, but we went from about 2,500 clashes at the start of Stage D down to double figure clashes. I think we're about 50 unresolved clashes at Stage E. And now then we opened up the game, got loads more now because we brought the trade involved, we're putting new aspects into it. But that's the process of design development. And a big part, how we get there, that's a series of coordination meetings. We use Navisworks, it's a great tool. So it's an ongoing process of coordination reviews. To get then to Stage E, we did that, but they're ongoing fortnightly meetings now as we go through. And then as we move forward, we're continuing to learn. The client's very much into what he can do from his FM point of view. The field to BIM side, so everyone was talking about as-built models. We won't have, at the end of this project, there won't be a process of as-built. We've got a Stage E model which has moved to F&G, it's on site. What we're going to do through the process is gather the on-site changes and update the model real-time throughout the whole process. So at the end of the project, the model will be updated to an as-built. So everyone's seen who builds the as-built, who draws the as-built information. It'll be there at the end of the job anyway, so it won't be an extra exercise. There's some good tools coming out now that allow us to do that. And then the other thing is that we've had to do as BIM coordinators in BIM technologies is that continuous coaching and mentoring, because there is a skills gap, there's no doubt about it. So our role has been in there supporting construction teams. From the architect's point of view on this one, the architect couldn't get up to speed fast enough for a delivery project, so we stepped in to model their information. So that's kind of, at the moment, we're in the kind of period of fixing various things. Whether or not a BIM coordinator has a role long term, I don't know, but at the moment there is a need because there's a skills gap. And then I'll move on to Adam's going to move you into the project now, because what we get in industry is there's a lot of theory, but this is the real model. This is on site now.
Just an aside thing I think to mention to you, I mean, if you're often wondering where is it important, is it going to slot in? I'm actually involved at the moment with the LEP in developing the assessment criteria for funding for projects that go to them. We've asked for 3 things mainly in them. First one being a localism, that everything is done locally from design through to construction. But the second one we've asked for, which they are going to include, is BIM. We haven't said we want BIM involved. We've asked, are you using BIM? And if you are, why? If you're not, why not? While stressing that we would prefer BIM is the way forward. So it is there, and that will take it into also the private sector looking for funding from elsewhere. So if I could just say thanks, and thanks to the speakers for coming, thanks to you guys on such a crap weather day, you've got to be honest. But I think it's been a very useful event, and if we could just give our speakers a final round of applause, and thank you.